Now in this lecture we'll find out the radius of the semicircle. In the drawing we have a semicircle and PA, line segment PA equals to 6 units in its length, and PA is also tangent to the semicircle at point A. Line segment PQ equals to 4 units in its length, and PS, line segment PS, cuts the semicircle at points Q and S. And we also know that line segment QC equals to line segment QS, and this angle PAB equals to 90 degrees, and this angle, this angle SQC, that is also equals to 90 degrees. Again, our mission is to find out the radius of this semicircle. Okay, so first of all I will present to you a new rule and we'll implement the new rule in our drawing. The new rule is rule number 10. According to rule number 10, in any circle, if AB is any chord in the circle, here AB is a chord in this circle, and PT is tangent to this circle at point T, then the following equation is true, that PT squared equals to PA times PB. Okay, so again, here PT squared equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because if you focus at point P, we have tangent PA, it's tangent to this to the semicircle at point A, and we have line segment PS that cuts the semicircle at points Q and S. Therefore we can implement here rule number 10. Okay, so if we focus at point P, according to rule number 10, we'll get that PA squared equals to PQ times PS. Repeat again. According to rule number 10, if you focus at point P, we get that PA squared equals to PQ times PS. PA equals to 6, therefore PA squared is 6 squared, that is 36, and it is equals to PQ, that is 4, according to what is given in the question, times PS. PS in total equals to 4 plus QS. In conclusion, we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we'll divide this equation by 4, and we get that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtract 4 from this equation, and we get that QS equals to 9 minus 4, that is 5. So if we found out that QS equals to 5 units in its length, we can write here that this line segment QS equals to 5 units in its length, but it is given us in the question that QC equals to QS, and QS is 5, therefore QC must be also equal to 5 units in its length. Okay, in the next step we will join points P and C together by a straight line. By joining points P and C, here we created here triangle PCQ. But before that, we will focus on the upper side on the lower side of the straight line PS at point Q. On the lower side of the straight line PS at point Q, the sum of the angles must be equal to 180 degrees according to the rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. I repeat again on rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. Here AB is a straight line. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have this angle that is alpha and this angle is beta. So in total, alpha plus beta must be equal to 180 degrees according to this rule number 3. You can actually implement rule number 3 in our drawing, because here, if you focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the lower side of the straight line PS at point Q to 180 degrees, the missing angle must be equal to 90 degrees. Therefore, triangle PQC is a right triangle. So, in the next step, I will copy the right triangle PQC in a new page, and we will implement the Pythagoras theorem in the right triangle PQC. Here by PT is a relation for Pythagoras theorem. Side PQ equals to 4 units, according to what is given as the question, and we just right now found out that side QC equals to 5 units. So this is the right triangle PQC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle PQC, PC square equals to PQ square plus QC square. So PC square, that is the square of the hypotenuse, equals to PQ square. PQ is 4. Therefore, PQ square is 4 square, that is 16, plus QC square. QC is 5, therefore QC square is 5 square, that is 25. So in total, we find out that PC square equals to 16 plus 25, that is 41. In conclusion, we found out that PC square, the square of the hypotenuse of this right triangle PQC, equals to 41. Okay. In the next step, I'll copy the right triangle PSC in the new page, and we'll implement the Pythagoras theorem in this right triangle PAC. Okay. PC equals to 41 units. PC square, here, PC square equals to 41. That is the square of the hypotenuse. Again, by PT is the variation for Pythagoras theorem. We define the length of side AC as A. So actually, this is the right triangle PAC that I covered from the original drawing. According to the Pythagoras theorem, in this right triangle PAC, we get that PC square equals to PA square plus AC square. PC square is 41, so we substitute PC square by 41, and it is equals to PA square. PA is 6, therefore PA square is 6 square, that is 36, plus AC square. AC is 8, therefore AC square is A square. In conclusion, we found out that 41 equals to 36 plus AC square. Here we subtract 36 from this equation, and finally we get that A square equals to 41 minus 36 is 5, A square equals to 5. Here we take a root out of this equation, and finally we get that A equals to the square root of 5. A equals to the square root of 5. So we can write here that AC, that is A, is equals to the square root of 5 units. This is a semicircle, therefore AB must be the diameter of this semicircle. I write it down. AB is the diameter of the semicircle. We define the radius of the semicircle as x, therefore the diameter must be equal to 2x. That is to say, AB, that is the diameter, must be equal to 2x. Okay? So AB is 2x and AC is square root of 5. So CB, from the drawing, it is very easy to see that CB equals to AB minus AC. That is to say, CB, this line segment CB equals to AB, that is 2x, minus CB, that is square root of 5. So in total, CB equals to 2x minus square root of 5. So I write it down here. CB equals to 2x minus square root of 5 units in its length. Okay. In the next step, we'll complete the semicircle to a circle. So we completed the semicircle to a circle, and we will extend side QC by a straight line until it touches the circle. And we will define the touching point of the extended side QC with this circle as point M. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. But before that, we will define line segment CM, this line segment CM as B. The new rule is rule number 11. According to rule number 11, in any circle, if chord AB intersects with chord CD at point O, then AO times VO equals to CO times DO. So here we have, inside this circle, we have two chords that intersect with each other. That is to say, chord AB intersects with chord CD at point O. Point O is the intersection point between the two chords. So whenever you have in a circle two chords that intersect with each other, then the following equation will be true. That AO times OB equals to CO times OD. AO times OB equals to CO times OD. So you can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord CM at point C. So I write it down. Chord AB intersects with chord QM and the intersection point occurs at point C. I repeat again, in our original drawing, we have chord AB intersects with chord QM at point C. Therefore, according to rule number 11, the following equation will be true. AC times CB will be equal to QC times CM. Repeat again. According to rule number 11, AC times CB equals to QC times CM. AC equals to square root of 5 times CQ, it is equals to 2x minus square root of 5 and it is equals to QC. QC is 5 times CM. CM equals to B according to our definition. So in conclusion, found out that according to rule number 11, we have here equation number 1 that states that square root of 5 times 2x minus square root of 5 equals to 5b. Here we divide this equation by square root of 5, equation number 1, and we get that according to equation number 1, 2x minus square root of 5 equals to 5 over square root of 5 times b. So here we add to this equation number 1, square root of 5, and we get that according to equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. In the next step, we will multiply square root of 5 by square root of 5 and then we will divide it by square root of 5 in order to have a common factor with this expression. And we get that 2x equals to 5b over square root of 5, and here we will multiply square root of 5 by square root of 5 and then we will divide it by square root of 5. So in this side of the equation we have 5b plus square root of 5 times square root of 5 is 5 over square root of 5. In conclusion, we found out that according to equation number 1, 2x equals to 5b plus 5 over square root of 5. I repeat again. According to equation number 1, we actually found out that 2x equals to 5b plus 5 over square root of 5. Here we'll divide this equation by 2, and finally we'll get that x, that is the radius that you're looking for, x is the radius of this semicircle, that is the radius that we are looking for, x equals to 5b plus 5 over 2 times square root of 5. So we actually succeeded to express the value of x in terms of b. Okay, this is CM is the length of line segment. B is the length of line segment CM. Repeat again, according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Okay. In the next step, we will join points S and M together by straight line. So here, inside this circle, we have peripheral angle MQS. This is peripheral angle MQS. That's equal to 90 degrees. And we have rule number 5 that says that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. That is to say, this peripheral angle MQS that is equal to 90 degrees must rest on the diameter of the circle. So MS is the diameter of the circle. I repeat again on rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have, inside this circle, we have peripheral angle MAN that is equal to 90 degrees. Therefore, this peripheral angle MAN rests on the diameter of the circle. That is to say, MN is the diameter of this circle. So we can actually implement rule number 5 in our drawing. Why? Because in our drawing we have this peripheral angle MQS that is equal to 90 degrees. Therefore, this peripheral angle MQS must rest on the diameter of the circle. That is to say, MS is the diameter of the circle. I'll write it down. Because of the fact that peripheral angle MQS is equal to 90 degrees, peripheral angle MQS equals to 90 degrees. Therefore, according to rule number 5, peripheral angle MQS rests on the diameter of the circle. That is to say, MS is the diameter of this circle. Because peripheral angle MQS rests on MS. Therefore, MS must be the diameter of the circle. So I write it down. According to rule number 5, MS is the diameter of the circle. Because of the fact that the radius of the circle is x, the diameter MS must be equal to 2x. So MS equals to 2x. It's twice as long as the radius. MS equals to 2x. So in the next step, I will copy the right triangle MQS in a new page, and we will implement on this right triangle, triangle MQS, the Pythagoras theorem. Side QS equals to 5 units instant. QM in total equals to 5 plus B. QM is QC plus CM. So in total QM equals to QC, that is 5, plus CM, that is B. So in total QM equals to 5 plus B. And the hypotenuse of the right triangle QMS is MS, and MS equals to 2x, that is actually the diameter of the circle. So actually, this is the right triangle QMS that I copied from the original drawing. The hypotenuse MS is 2x, it is the diameter of the circle. QM equals to 5 plus B, and QS equals to 5 units in itself. According to, here by PT is the progression from Pythagoras theorem. According to the Pythagoras theorem, in the right triangle QMS, we get that SM squared, that is the square of the hypotenuse, equals to QS squared plus QM squared. SM is 2x, therefore SM squared is 2x squared. And it is equals to QS squared. QS is 5, therefore QS squared is 5 squared, that is 25, plus QM squared. QM is 5 plus B, therefore QM squared is 5 plus B squared. In conclusion, found out that according to equation number 2, 2x squared equals to 25 plus 5 plus B squared. This is according to equation number 2. When according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Therefore, we can substitute x in this equation, equation number 2, by the value of x in equation number 1. We can substitute x in this equation number 2 by 5b plus 5 over 2 times square root of 5. We'll do it now, and we'll get that according to equation number 2, we have 2 times x squared, and x, according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5, so it is 2 times x squared. That is equals to 25 plus 5 plus b squared. In that side of the equation, we have 2 in the numerator and we have 2 in the denominator, so 2 will get cancelled. So in this side of equation number 2, we left only with 5b plus 5 squared. In the numerator and the denominator, we have square root of 5 squared is 5. And it is equal to 25 plus 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b is 10b. In conclusion, we found out that according to equation number 2, 5b plus 5 square over 5 equals to 25 plus 25 plus b square plus 10b. So we'll open the brackets on this side of equation number 2, and we'll get that according to equation number 2, so here we have 5b plus 5 square. 5b plus 5 square equals to 5b square, that is 25b square, plus 5 square, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b. So it is plus 50b over 5. And in the other side of the equation, we have it is equals to 25 plus 25, that is 50, plus b square plus 10b. So here, in this side of the equation, we have 25b square over 5 is 5b square, plus 25 over 5 is 5, plus 50b over 5 is 10b. In the other side of the equation, we have 10b plus b square plus 50. So here we have 10b on both sides of the equation, so 10b will get cancelled. In this side of the equation, we left only with 5b square plus 5. That is equals to, in the other side of the equation, we left only with b square plus 50. Here we subtract b square from this equation, equation number 2, and we get that according to equation number 2, 5b square minus b square is 4b square plus 5, that is equals to 50. Here we subtract 5 from this equation, equation number 2, and finally we get that according to equation number 2, 4b square equals to 50 minus 5 is 45. So 4b square equals to 45. Here we'll divide this equation by 4, and you get that according to equation number 2, this equation number 2, b square equals to 45 over 4. So b square equals to 45. We'll substitute 45 by 9 times 5 over 4. So here we take a root out of this equation, equation number 2, and finally we get that according to equation number 2, b equals to the square root of 9 times 5 over 4. So the square root of 9 is 3, and the square root of 4 is 2. So inside the root, we left only the square root of 5. In conclusion, found out that according to equation number 2, b equals to 3 times square root of 5 over 2. Repeat again. We found out that according to equation number 2, b equals to 3 times square root of 5 over 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times the square root of 5. So we can substitute b in this equation, equation number 1, by 3 times square root of 5 over 2. We'll do it now to get that according to equation number 1, x is the radius that we are looking for, x, the radius of the semicircle, equals to 5b. 5 times b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. So actually, according to equation number 1, x equals to 3 times 5 is 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. So here we will multiply 5 by 2 and then we divide it by 2 in order to have a common factor with this expression, and we get that according to equation number 1, x equals to 15 times square root of 5 over 2. So we multiply 5 by 2. 5 times 2 is 10, and then we divide it by 2. Okay, all divided by 2 times square root of 5. We'll move 2 times square root of 5 to the denominator, and we get that according to equation number 1, actually, x equals to 15 times square root of 5 plus 10 over 2 times 2 times square root of 5. So actually we found out that according to equation number 1, x equals to 15 times square root of 5 plus 10 over 2 times 2 is 4 times square root of 5. Repeat again, actually found out that according to equation number 1, x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. So according to equation number 1, x equals to, we take square root of 5 as a common factor from the numerator. So what is left from 15 times square root of 5 after we took from it square root of 5 as a common factor? What is left is actually 15 plus what is left from 10. Actually 10 is 2 times square root of 5 times square root of 5. So what is left from 2 times square root of 5 times square root of 5 after we took from it square root of 5 is a common factor? What is left is actually 2 times square root of 5. All divided by square root of 5 times 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out that x, that is the radius that we are looking for, x equals to 15 plus 2 times square root of 5 over 4 units. And in terms of numbers, this expression equals to 4.8680 units. And that is the answer to the question. Repeat again. The radius x of this semicircle equals to either 15 plus 2 times square root of 5 over 4. In terms of numbers, the radius x of this semicircle equals to 4.8680 units. Okay, so we finished to answer on this question. In the next step, I'll summarize the lecture. In this lecture, we found out the radius of this semicircle. It is given us in the question that line segment PA or tangent PA is tangent to the semicircle at point A, and the length of PA is 6. The length of line segment PQ is 4 units. And we also know that QS equals to QC. This is angle PAB that is equal to 90 degrees, and according to what is given us in the question, this is angle SQC that is also equals to 90 degrees. Again, our mission is to find out the radius of this semicircle. In the first step, I presented to you a new rule, and we implemented the new rule in our drawing. According to the new rule, that is actually rule number 10, in any circle, if AB is the chord in the circle, here AB is the chord in the circle, and PT is a tangent to the circle. You can see here that PT is tangent to this circle at point T. Point T is the point of tendency. Then the following equation is true. Here also we know that line segment PB cuts the circle at points A and B. In this way, actually, chord AB is created. So, according to rule number 10, the following equation is true, that PT squared equals to PA times PB. Again, PT squared equals to PA times PB. Okay, we can actually implement rule number 10 in our drawing, because if you focus at point P, PA is tangent to this semicircle at point A, and we have line segment PS that cuts the semicircle at points Q and S. For that reason, we can implement here rule number 10. So according to rule number 10, we get that PA squared equals to PQ times QS. I repeat again. According to rule number 10, PA squared equals to PQ times PS. PA is 6, therefore PA squared is 6 squared, that is 36, and it is equal to PQ, that is 4, times PS. PS in total, PS equals to PQ plus QS. That is to say, PS equals to PQ, that is 4 plus QS. So in total, PS equals to 4 plus QS. Here, PS equals to 4 plus QS. So, in conclusion, found out that 36 equals to 4 times 4 plus QS. Here, we divided this equation by 4. And finally, we found out that 36 over 4 is 9, equals to 4 plus QS. Here we subtracted 4 from this equation, and finally we found out that QS equals to 9 minus 4, that is 5. Here, this line segment QS equals to 5 units in its length, but it is given us a question that QS equals to QC, and if QS is 5, then QC must be also equal to 5 units in its length. Okay, then we join points P and C together by straight line, and we actually focused on the bottom side of the straight line PS at point Q. At the bottom side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. Repeat again rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. We have the straight line AB. If you focus on the upper side of the straight line AP at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have? At the upper side of AB at point Q, we have angle alpha and angle beta. So in total, alpha plus beta must be equal to 180 degrees. Here we can implement rule number 3. If we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have? At the bottom side of at the lower side of PS at point Q, we have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. Okay, and because of the fact that this angle equals to 90 degrees, it means the triangle PQC is a right triangle. So I copied the right triangle PQC in the new page and we implemented the Pythagoras theorem in this right triangle, triangle PQC. So actually, this is the right triangle PQC that I copied from the original domain. PQ equals to 4 units according to what is given in the question. QC equals to 5 units according to what we have already found out. And the hypotenuse PC is missing. So according to the Pythagoras theorem, here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle PQC, we get that PC square equals to PQ square plus QC square. So PC square, that is the square of the hypotenuse, equals to PQ square. PQ is 4, therefore PQ square is 4 square, that is 16, plus QC square. QC is 5, therefore QC square is 5 square, that is 25. So in total, PC square equals to 16 plus 25, that is 41. So in conclusion, we found out that PC square equals to 41. Here, PC square equals to 41. Then I copied the right triangle PAC in the new page and we implemented on this right triangle PAC the Pythagoras theorem. Actually, this is the right triangle PAC that I copied from the original drawing. PA equals to 6 units according to what is given as the question. We define the length of side AC as A, and we have already found out that PC square equals to 41. So here by PT is a version for Pythagoras theorem. In this right triangle PAC according to the Pythagoras theorem, we get that PC square equals to PA square plus AC square. PC square is 41 and it is equals to PA square. PA is 6, therefore PA square is 6 square, that is 36, plus AC square. AC is 8, therefore AC square is 8 square. So in conclusion, we found out that 41 equals to 36 plus A square. 41 equals to 36 plus A square. Here we subtracted 36 from this equation. And finally we found out that A square equals to 41 minus 36, that is 5. A square equals to 5. Here we took all out of this equation and finally we found out that A equals to the square root of 5. So AC, that is actually A, it is equals to 5 units in its length. Okay, AC equals to 5 units in its length. So we can write down here that in the original drawing, AC, that is A, it is equals to 5 units in its length. Because of the fact that this is a semicircle, AB must be the diameter of the semicircle. If we define the radius of this semicircle as x, then the diameter must be equal to 2x. So AB equals to 2x. Here AB is the diameter. We define the radius as x, therefore the diameter AB must be equal to 2x. So what is the length of side CB? CB equals to AB minus AC. That is to say CB equals to AB, that is 2x, minus AC, that is square root of 5. So in total, CB equals to 2x minus square root of 5. Okay. Then we completed the semicircle to a circle, and then we extended side QC by straight line until it touches the circle, and we define the touching point of the extended side QC with the circle is point M. Okay. Then I presented to you a new rule, and we implemented the new rule in our drawing. The new rule is rule number 11. According to rule number 11, in any circle, if chord AB intersects with chord CD at point O, then the following equation will be true, that AO times OB equals to CO times OD. Okay? We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. Therefore, according to rule number 11, repeat again. Chord AB intersects with chord QM at point C. Point C is the intersection point between the two chords. Therefore, according to rule number 11, we get that AC times CB equals to QC times CM. Repeat again. AC times CB equals to QC times CM. Okay. AC is square root of 5. CB is 2x minus square root of 5. QC is 5 and CB is B according to our definition. And CM is B. The length of line segment CM equals to B units according to our definition. So, we actually found out that according to rule number 11, square root of 5 times 2x minus square root of 5 equals to 5b. Here, we divided this equation number 1 by square root of 5, and we found out that 2x minus square root of 5 equals to 5b over square root of 5. Then we added square root of 5 to this equation number 1, and finally found out that 2x equals to 5b over square root of 5 plus square root of 5. Then we multiplied square root of 5 by square root of 5, and then we divided by square root of 5 in order to have a common factor in this expression. So we get here that 2x equals to 5b over square root of 5, and here we multiply square root of 5 by square root of 5, and then we divide it by square root of 5. So here we have 5b, the numerator of 5b plus square root of 5 times square root of 5 is 5. So in total, in the numerator, we have 5b plus 5 over square root of 5. In conclusion, we found out that 2x equals to 5b plus 5 over square root of 5. Repeat again. We found out that according to equation number 1, 2x equals to 5b plus 5 over square root of 5. And finally, we divided this equation number 1 by 2, and found out that x equals to 5b plus 5 over 2 times square root of 5. Okay, so actually succeeded to find the value of x. We succeeded to express the value of x, that is the radius of the semicircle, that is the radius that we are looking for. We succeeded to express the radius x in terms of b. Okay. So here, then we join points S, M, and M together by straight line. In the drawing, we have peripheral angle MQS. This peripheral angle MQS equals to 90 degrees. And this peripheral angle MQS that is equal to 90 degrees rests on chord MS. Here we have rule number 5. that relates to a peripheral angle that is equal to 90 degrees. According to this rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have, this is peripheral angle MAN that is equal to 90 degrees. Because of the fact that this peripheral angle MAN equals to 90 degrees, therefore it must rest on the diameter of the circle. So this peripheral angle MAN rests on MN, therefore MN must be the diameter of the circle. We can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. This peripheral angle MQS that is equal to 90 degrees rests on MS. Therefore, according to rule number 5, MS must be the diameter of the circle. Repeat again, because of the fact that peripheral angle MQS equals to 90 degrees, according to rule number 5, this peripheral angle MQS must rest on the diameter of the circle. It rests on MS, therefore MS must be the diameter of the circle. Okay? And the radius of the circle is x, therefore the diameter MS must be equal to 2x. Again, repeat again, the diameter MS of this circle must be equal to 2x. Then I copied the right triangle MQS in a new page, and we implemented the Pythagoras theorem in this right triangle MQS. This is the right triangle MQS that I copied from the original drawing. Side QS equals to 5 units inside. QM, in total QM equals to 5 plus B. QM equals to 5 plus B. And we just right now found out that SM is the diameter of the circle that is equal to 2x, according to rule number 5. So in this right triangle MQS by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, SM square equals to SQ square plus QM square. Repeat again, SM square equals to SQ square plus QM square. So SM is 2x, therefore SM square is 2x square, and it must be equal to SQ square. SQ is 5, therefore SQ square is 5 squared, that is 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. So in conclusion, found out that according to equation number 2, 2x square equals to 25 plus 5 plus b square. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times root of 5. Therefore, we can substitute x in this equation number 2, by 5b plus 5 over 2 times root of 5. We did it, and we got here 2x squared is 2 times x is 5b plus 5 over 2 times root of 5 squared. So this expression equals to 2x squared, and it is equals to 25 plus 5 plus b squared. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So, and we left only with 5b plus 5 squared over square root of 5 squared. Square root of 5 squared is 5. So in this side of the equation, we left only with 5b plus 5 squared over 5. On the other side of the equation, we have 25 plus 5 plus b squared. I'll repeat again. In this side of the equation, we left with 5b plus 5 over 5b plus 5 square over 5. On the other side of the equation, we left with 25 plus 5 plus b squared. So it is 25, and 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b plus 10b. So in the other side of the equation we left with 25 plus 25 plus b squared plus 10b. Here we open the brackets on this side of the equation number 2 and found out that 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, 10b times 5 is 50b, all divided by 5, and it equals to 25 plus 25 is 50, plus b squared plus 10b. So here we have 25b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b. This is equals to 10b plus b squared plus 50. Here we have 10b on both sides of the equation, so 10b will get cancelled. So in this side of the equation we left only with 5b squared plus 5. That is equals to b squared plus 50. Here we subtracted b squared from this equation, equation number 2, and finally found out that 5b squared minus b squared is 4b squared, plus 5 equals to 50. Here we subtracted 5 from this equation, and finally found out that 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45. Here we divided this equation, equation number 2, by 4, and finally found out that b squared equals to 45 over 4. So b squared equals to 45. We substitute 45 by 9 times 5 divided by 4. Then we took out of this equation, equation number 2, and finally found out that b squared equals to the square root of 9 times 5 over 4. The square root of 9 is 3, and the square root of 2, and the square root of 4 is 2. So 3 over 2 is outside the root. Inside the root we left only with 5. So in total we found out that b equals to 3 times square root of 5 over 2. Repeat again. Actually found out that b, according to equation number 2, b equals to 3 times square root of 5 over 2. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So we can substitute b in this equation, equation number 1, by 3 times square root of 5 over 2. We did it and found out that according to equation number 1, x equals to 5b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. 5 times 3 is 15, so this expression equals in total to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. Here we multiplied 5 by 2 and then we divided by 2 in order to have a common factor with this expression. And here we get 15 times square root of 5 over 2, and here 5 times 2 is 10, and then we divided that 10 by 2. So we change nothing. All divided by 2 times square root of 5. Here we moved 2 times square root of 5 to the denominator, and finally we found out that 15 times square root of 5 plus 10 equals to 2 times 2 times square root of 5. 2 times 2 is 4. So in conclusion, found out that x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. Then we took square root of 5 as a common factor from the numerator. We know that 10 equals to 2 times square root of 5 times square root of 5. So we took square root of 5 as a common factor from those two expressions. What is left from 5 times what is left from 15 times square root of 5 after we took from it square root of 5 as a common factor? What is left? It is actually 15. What is left from 2 times square root of 5 times square root of 5 after we took from it square root of 5 as a common factor? What is left? It's actually 2 times square root of 5, all divided by square root of 5 times 4. We have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled and we're left only with x that is equals to 15 plus 2 times square root of 5 over 4. So x, the radius x of this semicircle equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units. Okay, thank you very much.